welcome back to part 2. Now, when dealing with multiple linear roots, multiplicity, in the denominator, each power gets its own fraction. This is a little bit tricky. To solve, we're going to use the same technique, but we're going to have an extra remaining numerator, and we're going to use another convenient number. We will do this a lot in calculus, so this is kind of a tricky one here. So let's go and take a look here. So if I were to write this out, same thing, but be careful. I actually have 3 factors in the bottom. I have x, x plus 1, and I have this other one, another x plus 1. So each one gets its own fraction. I have the one for the x, another one for an x plus 1, and then I have this other x plus 1. But remember, it says each power gets its own fraction. So actually I have to write that as x plus 1 squared. Now these are all still linear factors here. X to the first, x to the first, x to the first. Then we're just going to give each one an a, a b, but this time we have to use a c. Now, when you multiply by the LCD, be really careful. It's going to be x, x plus 1 squared. So when I multiply through, we're still going to get this 5x squared plus 20x plus 6. The a, it has the x. What's it missing? The x plus 1 squared. The b, it has the x plus 1. It's missing an x, but it's also missing another x plus 1. So I have to write that out. The c, it has the x plus 1 squared. It's just missing its x. And I solve it the same way. I'm looking for zeros. Now the only zeros that I have, 1, x equals negative 1. From here. So if I plug in negative 1, that's going to give us 5 minus 20 plus 6 equals, that becomes 0a plus 0b, be careful, minus c. Now use a little bit of mathematics, and I've already done this for you. You wind up with c equals 9. Then I go to my next 0. Now, I already have x minus 1, so my other one must come from this x right here. X equals 0. If I plug it in, we like that. 0 plus 0 plus 6 equals, be careful, 0 plus 1 is 1, square root 1, so we just get a, plus, this becomes 0b, because 0 times anything, just 0, plus 0c. So the b and the c don't matter, and we get a equal to 6. Now, here's where the problem is. I have no more zeros. I can't use negative 1. I can't use 0 again. They're just going to solve for 6 and 9 respectively. So what we're going to do is we're going to pick a convenient number. See, I already know what A and I already know what C are. To find B, what I'm going to do is I'm going to pick a convenient number. X equals, now, I already used negative 1. I already used 0. I'm not going to go crazy. I'm not going to pick like, oh, 10. You could. It will work. But, hey, who wants to be 11 squared all the time, right? So I'm going to pick one that's close to it. 1. I haven't used 1 yet, so I can use 1. When I plug it in, this becomes 5 plus 20 plus 6. Now, mind you, we already know what A is. A is 6. And what's 1 plus 1? 2, square it, we get 4. Plus, we're looking for B, that's 1. 1 plus 1 is 2. And C, again, we already know what C is. It's 9 times X is 1. And now take a look. The only variable I have now is B. Over here we get 31 equals 24 plus B plus 9. And solving it, we wind up with B equal to negative 1. And now I have it all out. I can rewrite it now. A, 6 over X, plus B, negative 1 over X plus 1, plus C, which is 6 over X plus 1 squared. And that is the decomposition of our rational function here. And there we go. That's our decomposition there. All right, so let's try number 5. See if we can set up number 5. Don't worry about number 6. That's kind of a review question for you. Messed up there. Oops. But let's take a look at number 5 right now. So I have multiplicity. It is a linear root. Now wait till it's a nonlinear root with multiplicity. Woo! Baby, baby. So I'm going to set it up. I have 2 factors on the bottom. Be careful. So I need 2 sums. Ready? This one has an x minus 5, but under here, remember, because I'm squaring it, each power gets its own. Now, I know what you're thinking. What if the power was 3? You would x minus 5 squared, x minus 5 cubed. All right, so let's take a look here. Now, to solve this one, an a and a b, because they're linear, so I use a and b, and I look for the zeros. Now, our LCD is pretty easy. It's just x minus 5 squared, right? So if I set this up, I'm going to get, this just cancels, 4x squared plus 3 equals, the a, it's missing an x minus 5. Now take a look. The b, it's not missing a thing, so we just leave it as b. This is kind of a cool one because guess what? We only have 1 0. X equals 5. If I plug it in, 25 times 4 is 100, so we get 103 equals 0a plus b. b equals 103. So I know what you're thinking. We have b. How do we find a? Well, once again, just like before, I'm going to pick something convenient. So I pick a number. I use 5. What would be another number to use? 0 is a perfectly good number to use. So if I plug my 0 in, we get 0 plus 3 equals, we know what a, we're looking for a, negative 5 plus b, which we just found is 103. So that's 3 equals negative 5a plus 103. Bring over the 103. That's negative 100 equals negative 5a. A equals 20. Very easy to do. These are kind of fun to do. I'm challenged, Mr. Warner. Thank you, finally. You're welcome. So I can decompose this. A, 20 over x minus 5 plus b, which we know is 103 over x minus 5 squared. Ta-da! And there's our decomposition. Look, we're decomposing. That's funny. All right, anyways, don't worry about 6. Try it if you want to. It's just a practice of the other ones. But I do want to look at 7 with you. At least get it started. This is a little slightly harder one because if you notice, x squared, x minus 1 squared. How many factors are there? 4. Ew. We might have to continue this one on the other side. X, each power gets its own, x squared, x minus 1 squared. A, B, C, D. All right. Didn't know you'd be doing the alphabet in here, all right? So, how do we start this? What's our LCD? It's x squared, x minus 1 squared. Remember, that's really your LCD. So when you multiply out, we get 6x squared plus 1. That's just going to cancel. The a, what's the a missing? It has an x. It's missing 1x, and it's missing the x minus 1 squared. The b, it has the x squared. What's it missing? The x minus 1 squared. The c, it's missing the x squared and an x minus 1. The d, it's missing x squared. All right. So, what I would like to do, you might need another sheet of paper. I'm going to go and switch to another sheet of paper just to make sure we have enough room here. So, alrighty, let's take a look here. So, I switch to another sheet of paper just to make sure we have enough room. Look for the zeros. What's the 0? X is 0. Good. So, if I plug it in, 0 plus 1 equals 0a plus, be careful, 0 minus 1 is 1. Square that, we get b, just 1b, plus 0 squared, still 0. 0c plus 0d. Doop, 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 doop. B equals 1. What's my other 0? X equals, comes from here, 1. Very good. That's awful. X equals 1. Okay? So x equals 1. If I plug the 1 into the equation, be very careful. 6 squared plus times 6 is, 1 squared plus times 6 is 6 plus 1 is 7 equals, be careful, 1, so we get a times 1. 1 minus 1, 0. Oh, wow, how cool is that? Plus 1 minus 1 squared is still 0b. Plus the c becomes 0. Plus the d, we get 1 right there. Goes away, goes away, goes away. D equals 7. But now our fun begins. Now we have to start making up stuff. Now's the point where we got to start making up things. Now I'm going to scroll this down just so we can see it. Okay. Remember, let me take a look here real quickly. D, B we know is 1. D we know is 7, just so I don't forget about those. Okay. So when I go down here and I'm going to solve these now. Hold on. Sorry about that. I have to make up a number. I already used 0 and 1. What could I use next? Yeah, negative 1. Why not? Plug negative 1 in, that stays just 7. Negative 1 squared is 1 times 6 plus 1 is still 7. But when I plug a negative 1 in here, I'm going to get A, negative 1 times, what's that? 4. Very good. Plus B, we already know B is 1. Negative 1 minus 1 squared is 4. C, we don't know what C is, but we're going to get 4 times negative 1 minus 1, negative 2. And D, we know is 7, and that's just going to become 1. Clean it all up. 7 equals negative 4A plus 4 minus 8C plus 7. Notice we have two variables here. Now the fun truly is going to begin for us, okay? So when I set this up here, we're going to get negative 4A minus 8C. Now the 7's cancel, and that's going to equal a negative 4 right there. Now let me just double check the C right here. Make sure that's correct. C. Ooh, did I mess up here on the C? I did. So that should be negative 1. This should just be a 1 right there, which makes that a negative 2. So let's make sure we fix that. That should be a negative 2C right there, okay? So we have, yeah. All right, so I'm going to keep that. Now, I'm going to pick another 0. What can we pick? Try 2. I do the same thing, okay? We're going to get 4, 24, so we get 25 over here equals, plug in 2. Again, we don't know what A is, but if I plug in 2 here, that's going to become 2 minus 1, which is 1, plus B, we know B is 1, plug in 2, that just becomes 1. C, we're looking for C. We plug in 2, we get 4 times 1, right? 4 times 1, that's 2 minus 1. Plus D, which we know is 7, and 2 squared is 4. So we get 25 equals 2A plus 2 plus 4C plus 28. And let's see what we got here. 2A plus 4C, this becomes 30 equal to negative 5. Negative 5 right there, okay? All right, now, what we notice here, 2 equations, 2 unknowns. We have a system. So we can get 2A plus 4C equals negative 5, and the A is negative 4A minus 2C equals negative 4. And what I would like you guys to do is solve it. I'll give you a hint. Multiply the bottom by 2, and that's going to eliminate your C's. And we'll go finish up on this one tomorrow, okay? I know it's kind of lengthy. Try this one again. It's a very hard one, okay? 7's hard, okay? But we'll see you tomorrow, okay? Thank you.